So before we begin this section 2.1 video on graphing linear equations, I'm just going to refresh your memory about the coordinate plane or also the Cartesian plane. I'm not going to make a real big lesson out of this. Hopefully you still remember this from your previous years. But a Cartesian plane has two axes. It has a y-axis and it has an x-axis. And your job on these types of planes is if you get what's called an ordered pair. And the ordered pair is a point on side of this Cartesian plane. Now, if this is, like I said, I'm not teaching that per se. I'm just kind of reminding you, because what we're about to do over the course of basically for the rest of your career in this class is we're going to be working a lot with graphs. So if you do not understand how a Cartesian plane works and you do not understand what ordered pairs are or anything like that, please come find me and I can give you a review. You'll probably pick up on it pretty quick as we go along through this video, but just in case you're struggling and you need to kind of have a refresher on what this is about, please come see me. Now, with that, we've got that little disclaimer out of the way. Let's go ahead and start talking about section 2.1. So, in this one, we're going to be graphing linear equations, and right now we're going to do it the hard way. And what is a linear equation? First off, it's an equation whose line is a graph. So I will be giving you some equations, and your job is to graph that line on the coordinate plane. And when you do, you're going to get a straight line, and you'll see that in a minute. The next one here is solutions. It's basically all the points of a line. So when you draw that line, all the different points that are on that line are what we call solutions. And I'll show you that again. So how do we go about doing this? All right, so we're going to do it the first way. We're going to graph a linear equation by making a table. So I've got a little table here. I have an x, I have an equation, I have a y, and I have an xy. So just to kind of touch base on what this table is about, this right here, this x represents my input. This is a term you're going to hear me saying, input. It also represents what I call the independent variable. All right, so these two terms that you've heard, you're going to hear me use those interchangeably. Input, independent variable, and your x value, all three of these things mean the same thing. You are going to hear this basically for the rest of your math career. Your x is your input, your independent variable. Well, what is y? Well, this is what we call my output, all right? And it's also called the dependent variable. Okay? Now, we're not going to be going over these definitions, and right now you will be seeing it a whole lot more when we get into something called functions, but that's a story for another day. Just know that these terms are interchangeable. If I say input, I'm talking about x. If I say dependent variable, I'm talking about my y. All right, and then lastly here, I have xy in parentheses. This should be somewhat familiar to you, and as it is my ordered pair. That's what I'm going to use to plot points on my graph. So if I want to plot my equation, in this case is y equals x plus 2, my job is just to make some random numbers up. So I'm going to use some numbers. I'm going to use the numbers, say 0, and I'm going to use 0 and 1. So what this is telling me is when x is 0, I'm going to plug that into my equation. So y is equal to x is 0 plus 2. Well, what's 0 plus 2? That's going to give me 2. So when x is 0, y, according to this equation, is 2. So that gives me my input of 0, my output of 2, and that creates an ordered pair. Well, what was my x? It was 0. What was my y? It was 2. So I have this ordered pair. Now I'm going to do the same thing. Again, did it matter what number I used? No, I just did 0 and 1 because, hey, I like those numbers. So I plug 1 into place of x. Y is equal to 1 plus 2. Well, what's 1 plus 2? It's 3. So my input was the number 1, and it gave me an output of 3. So my ordered pair for this would be 1 and 3. Now, just to show you what we would do now is to plot the ordered pairs. I'm going to just do a little bit of scrap work over the side. It's not got to be perfect right now because I want you to see the concept more than I am the exactness of things. So the first one says 0, 2. That's my first ordered pair. So I'm going to put a point right here. This represents 0, 2. All right? And then the next ordered pair was 1 and 3. So we're going to pretend that it's right here. Okay? Here's my next point, and that's my 1 and 3. All right, is this exact? No, but I really want you to see the point more than I do all the perfect details. Now that I have my 2 points plotted, it says just simply draw a line. So I am going to basically connect my dots. Okay? And that's it. So I've drawn my line. And another little piece about this, and you're going to see me do this often, is drawing arrows. So what that is this equation that I've just graphed, all the possible answers, all the possible solutions fall on side of this line. So this answer, there's an answer here, there's an answer here, there's an answer here, there's an answer here, here, all the way into infinity. And then it's the same thing the opposite way. All right, so this is a basic understanding of how we graph it using a table. So we do have a couple of what we call special cases. So let's say you have an equation such as y equals b. Really, all it is a horizontal line that goes through the y-axis at b. So what does that say? So let's just simply say it. Y equals 3. If I were to graph this, there's my y-axis and here's my x-axis. I'm going to draw a horizontal line which looks like this, and it's going to go through the y-axis at 3, and I'm done. It gives me a horizontal line at 3, and it goes through the y-axis at 3. Well, what about this one? X is equal to A. Well, this gives me a vertical line that goes through the x-axis at A. So if I give you x is equal to -5, and I try to go graph it, so here's my y-axis, here's my x-axis, -5 would be somewhere around here, and I would draw a vertical line going through -5, like so, and I'm done. So these are special cases. One, when you have a regular equation, you use a table, make up some numbers, plot them, and see what it does. If I have a y equals a certain number, y equals b, it's a horizontal line, and if it's x is equal to a, it's a vertical line. So let's take a look at some things. First off, very first problem, y is equal to 4. Well, if you notice, this right here is one of my special cases, and because I know it's a special case, it's going to be a horizontal line. The question is, where do I put it? Well, notice that these are not labeled, so we can label it ourselves if we want to. So we can label this as 1, 2, 3, and 4. That will be fine. And this would be -1, -2, -3, -4. That's fine. Or we can count by twos. 2, 4, 6, 8. This would be -2, -4, -6, -8. Well, what would this be going this direction? Let's count by twos again. 2, 4, 6, 8. And this one would be -2, -4, -6, -8. And that's fine. So I've labeled my axis. Now, what did you notice about my labeling? Notice that I counted by the same spacing, the same number. I counted by twos. So that's very important when graphing, making sure that these are counting in the same spacing. Now that I've done that, it says y equals 4. I know it's a horizontal line that's going to go through 4. So I'm going to use my handy dandy straight edge here, protractor in this particular case, and I'm going to draw a line right through 4. And I'm going to put an arrow here, and I'm going to put an arrow here because it goes on through infinity. All right, now, here's the next one. Y equals -1/3 x. Well, this is not a special case, so my job for this one is to create a graph. I mean, not a graph, but a table. So I'm going to have x. I'm going to create my equation y is equal to negative 1/3 x, and then I'm going to have my y, and then I'm going to have my ordered pairs to the side, and then I'm going to kind of fill in the rest of my graph so I can see it. And in this particular case, let's use 3 numbers, okay? So what numbers do we want to use? Well, the easiest number to start with right off the bat is 0. That's easy. Use a 0. The next thing we want to do is to try, since I know this is a fraction, why don't we get rid of that 3 somehow? So notice that the denominator is a 3. So in order to get rid of a fraction, why don't we multiply it by the denominator? So let's use the number 3 instead. So what's another number we can use? Well, we know that the denominator is 3, so why don't we use a negative 3? Okay, this is going to cancel some numbers out, and it's going to give our y value a nice even number. We don't have to worry about fractions. Could I use any other number? Absolutely. But why work so hard? Get rid of that fraction by multiplying it by its denominator. So let's plug things in. Y is equal to negative 1/3 times 0. Well, what's negative 1/3 times 0? It's 0. That's easy. So my ordered pair is going to be 0 and 0. Let's do the next one. Y is equal to negative 1/3 times 3. Well, if you don't know how to do this in your head, you can use a calculator, but I'm going to go ahead and tell you when I do this, I'm going to get negative 1. So my ordered pair would be 3 and negative 1. Let's do the last one. Y is equal to negative 1/3 times a negative 3. Well, I can do this one in my head again, and I'm actually going to get a positive 1. Don't know how I did that? You can use a calculator, absolutely fine. So my ordered pair would be negative 3 and positive 1. Now I have 3 points, so let's kind of look at our graph. How do we want to do it? Well, we can count by 2s like we did last time, but let's just, since we got some small numbers, let's just count by 1. So this would be 1, 2, 3, and this would be 4. And then you could do the same thing up here. 1, 2, 3, 4. This would be negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4. All right, now that I've got it all labeled, let's plot the points. My first ordered pair is at 0, 0, which is what we call the origin. So I can plot that point right there. The next one would be at 3 and negative 1. So this would be 3 and negative 1, which we could plot that point right there. The last one would be negative 3 and positive 1, so we could put it right here. So I've plotted my 3 points, and now it's just a matter of connecting the dots. Now you're going to hear me say this a lot. Make sure, this is really important, especially later on when we're looking for what's called y-intercept. Make sure that you've got a really good pencil and a really good straight edge, because if you're not getting your lines drawn just right, it's going to mess you up on some of your future problems. Okay, just be aware of it. So we want to make sure it's just right. Now that I've drawn my arrows, it's done. All right, so the next one, it says solve for y, then graph the equation. Well, I'm going to help you out on this, and I'm going to kind of leave these two to your own. So actually, no, I'll help you out with 3 a little bit. So recall from last chapter, one of the last things you did is you had to solve for a variable. Well, that's what you're doing right now. We have to solve for y. We have to get this y by itself. So my job right now is to get rid of this plus 2x. How do I do that? Well, let's go through SADMAP it. So what do I need to do? I need to subtract this whole thing from both sides. And when I do, I get the new equation. Y is equal to 3 minus 2x. Now that I know what my equation is, it's just a matter of making my graph. So x, I'll put a y here, and then my ordered pair x and y. I'm running out of room. Yoink, yoink, yoink. And I didn't have to draw all that many. So we'll use 3. So now that I've got my equation rewritten, I can just plug things in. The one thing that I always suggest you do, use your first number to be 0. That's just going to make your life easy. Then try to use a number like this one right here does not have a fraction, so we can use any number we want. But let's just use a positive 1. Why? Why not? Could I use 2? Absolutely. Could I use 3? Absolutely. Doesn't really matter. But for now, I'm going to use 1. And then I like to do this. I like to use its opposite. So if I use 1, I like to use -1. And that's 3 points that we can use. Now it's just a matter of plugging everything in. Y is equal to -3 minus 2 times 0. Well, what's 2 times 0? It's 0. What's 3 minus 0? Well, that's going to be 3. So my first order pair is 0, 3. Okay? Then I'm going to do the same thing. Y is equal to 3 minus 2 times 1. Well, 2 times 1 is 2. 3 minus 2 gives me 1. So that gives me 1, 1. Now I'm going to do the same thing for this one. Y is equal to 3 minus 2 times -1. All right, well, -2 times -1 is going to give me a +2. So this right here is actually going to give me a 5. All right, so -2, if you don't believe me, I'll do it another way. I'll show you. 2 times -1 gives me 3 minus a -2. Okay? 3 minus -2. And what's 3 minus -2? Well, it's 3 plus 2. And that gives me my 5. So my point for this one, my ordered pair would be -1 and 5. Now that I have my 3 points, it's just a matter of labeling it. Well, we do have a little bit of an issue here. If we count by ones, notice that we only go up to 1, 2, 3, 4, 5. So probably in this case, it might be better to count by 2s. And because I'm lazy right now, I'm not going to label it like I did these other ones because we can count by 2s. All right, so my first one is at 0, 3. So here is 0. This would be 2, and this would be 4. So 3 would be right here in the middle. So that's 0, 3. I will write 0, 3 by it, okay? My next one is 1, 1. So this would be 2. So this would be 1, and this would be 1. So here is 1, 1. Okay? And then lastly, I have -1 and 5. So -1 would be on here, and this is 2, 4, and that would be -1 and 5. So I've plotted it right here. Now that I've got my 3 points, it's just a matter of drawing it out. Okay? And then making my arrows because this equation is an infinite line. So what I'm going to get you to do is I want you to try number 4 on your own, all right, and come back and see how you did. All right, so for number 4, what you should have done first is solve for y. What I did is I had to add 3x to both sides, and I got 2y equals 1 plus 3x. Then I had to divide by 2. If you had left your equation at this, that's correct, but I'm going to make up a Mr. Lewis word. This is corrector. All right, there's a reason for this. Later on, we're going to be talking about why this is the best answer compared to this. But for now, if you did this, you're fine. If you went to this step, that's even better. So how did I go from here to here? Well, I needed to understand that that 1 is being divided by 2. So 1 divided by 2 is 1/2. And that 3 is being divided by 2, so 3/2. All right, so just recall that if you did this, you're okay, but this is your better equation, and there is a huge reason for that later on down the road. Now that we've done that, you should have created your table. I didn't do that for the sake of this video, and you should have had something that looks like this. Now, for me, I actually counted by 1, so this point right here is actually 0 and 1/2. So, and then this point right here would be 2 and, 3 3/2. 2 3/2. So those were my 2 points that I've got, and I'm not going to do the ones down here, but that's what you should have gotten. If you're stuck on this, please let me know. So let's take a look at number 5. 5, the equation y equals 2x plus 4 represents the cost y in dollars. So this is my output. This is my dependent variable of renting a movie 8 days after late charge. So this is my dependent variable. Graph the equation. Well, I'm going to let you do that on your own. And then once you graph your equation, it says use the graph to determine how much it costs after 3 days. So I'm not going to graph this, but I am going to just do a little bit of a sketch. Let's just say, for the sake of argument, I don't want to make this too good. I don't want to give you the answer. Yeah, this will work. This will work. Let's say that after I have graphed this, I got this equation. Line like this. This is not correct, by the way. It's not correct. But let's say I did. It's telling me to use the graph to determine how much it costs 3 days of late charge. Well, what are the days represented? Well, they're my x. So if I look and go over to my x at 3, well, this would be 1, 2, 3. So at this, I can trace it up to my line right here, and I can find out that after 3 days, it's only going to cost me, according to this, $1. All right, so that's how you do it. You would chase your 3 days, this would be your days, and you would trace it up to your x. All right, so I'm not going to give you any more of a hint than that. This type of question is imperative that you understand how to work with it, because you're going to see a lot of these on the EOC. So make sure you are talking to me about these, especially understanding cost is what we call dependent, the y, and x is my independent or my input. So make sure that we understand that. You're going to see a lot more of those terms coming up. So I want to get you interested into them now. And that's it for this video, and I will see you in the next one. Bye-bye.